Welcome back to Geometry Classroom. Today we'll learn about compound probability. In this lesson, we'll define the probability of an event, compound events, and we'll learn how to calculate the probability of a compound event, or so-called compound probability. Now, first, let's recall the definition of probability. Probability of an event is a numerical value from 0 to 1 that measures the likelihood of an event. We can write the probability of an event as a fraction, decimal, or percent, right? In other words, a probability of an event, it's a number between 0 and 1. Good? An event is a single outcome or a group of outcomes. Yes? When the event is a group of outcomes, these outcomes could be related by word and or the word or, right? And in this case, we call this group of events compound events, right? Now, we divide this lesson into two sections. First, in this lesson, we'll talk about finding the probability of two events linked by word and in another lesson, we'll learn how to compute the probability of two events linked by word or. Now, we have two main types of events, right? We have independent events and dependent events. Independent events are two or more events that occur in a sequence. If the outcome of any event does not affect the outcome of the other event, we call these events independent. If the outcome of any event changes or affects the possible outcomes of the other events, then these events are called dependent, right? Now, when two events are related by word and, the probability of event A and B is the product of probability of event A and the probability of event B. Yes? Now, let's have a few examples with problems of compound events, right, related by word and. In this example, it says there are two jars. One jar has 2 orange marbles and 3 red marbles. The other jar has 1 blue marble and 4 green marbles. If Jeff randomly draws 1 marble from each jar, what is the probability that he will draw a red marble and a green marble? First, we have to identify the events. Event A, or let's say first event, is drawing a red marble, right, from the first jar, right? This is event A. Event B is drawing a green marble, right, from the second jar. Yes? As we can see, events A and B are related by word and. right? So, as we can see, these two events are independent, right? So, if we apply the formula of P of A and B, right, which is the product of probability of event A and probability of event B, we'll get. As we know, the probability of an event is the number of favorable outcomes over the total number of possible outcomes. If we look at the first jar, right, there are in fact, three possible favorable outcomes to get a red marble. Why? Because there are three red marbles. So this number is on top of the fraction. What is the total number of possible outcomes for the first jar? Is 2 plus 3 is 5, yeah? So this is placed in the bottom of the fraction. Now, we multiply by the probability of event B. What is the probability of getting a green or drawing a green marble? So, we have 4 possible favorable outcomes here because we have 4 green marbles. So, on top will be 4. And the total number of possible outcomes for the second jar is 1 plus 4 because you have a total of 5 marbles also, right? Good. All we need to do is to multiply these fractions because they cannot be simplified. We simply multiply tops and bottoms. So we're going to have 3 times 4 is 12, 5 times 5 is 25. And that's the probability of drawing a red marble and a green marble. Let's have another example. In this example, yes, we have an experiment that is broken up into 2 parts. In the first part of the experiment, a 6-sided die is rolled, yes? In the second part of the experiment, a dime is tossed in the air. What is the probability of getting a 4 and heads as the outcome? Yes? Now, in this example, right, we have, again, 2 events. The first event is getting a 4 when you roll a die. Yes, this is so-called event A. Event B is getting a head as we toss a dime in the air, right? Again, these events are related by word and, right? So we have to find P of A and B. Of course, these 2 events are independent. Why? Because the outcome of the first event, rolling a dice, doesn't affect the outcome of the other event, that is tossing a dime. So, P of A and B, right, as we know, is the product of probability of event A and the probability of event B, right? Now, what is the probability of event A of getting a 4 when we roll a die? We have only one possible favorable outcome to get a 4, right? Because there is only one face with the number 4, right? So we have 1 out of 6, because we have 6 possible outcomes when we roll a die. Good. Now for the second event, getting ahead when we toss a dime in the air. What is the number of favorable outcomes? Is just 1, because a coin has only one head, right? Out of 2 possible outcomes, right? Because a coin has 2 faces, right? So it would be 1 over 2. Again, these 2 fractions cannot be simplified, and we simply multiply them, right? By multiplying tops and then bottoms. 1 times 1 is 1. 6 times 2 is 12. That's the probability of getting a 4 when we roll a die and getting a head when we toss a die. Good. This being said, that's all we have for today. We'll have another lesson later with the probability of event A or B. Thank you for watching my video.